All right, welcome to class. With us, we are still dealing with the third method in solving differentiation, and we have these questions on the board. How do we go about this? First thing is first, we know that in applying chain rule, I already told you my formulae for chain rule. My formulae for chain rule is this, which will give us dy over du times du over dx. So next thing going further is that the first thing we want to use to solve this method is simply we are going to change this value and bring this down like this, applying indices. We say 2, this 2, then we bring it as times 1 all over. I will remove this root, this cube root now. I'm going to have 2x squared plus 5 all raised to the power of 1 over 3. So because this is 3, I'm having it as 1 over 3. Now next up, what do we know? We know that in indices, if I have 1 over a, I can change it to a raised to the power of minus 1. Removing this division, I'll change it to a raised to the power of minus 1. So I know all of that one. So same thing applicable here. So I'll have 2, then I'll have into brackets. Observe what I'm going to do now. This becomes 2x raised to the power of 2 plus 5 all raised to the power of minus. So I'm removing this divide now, and then I'm changing this into this. So please, this is power, please. This is power. So what do we do next? I already told you that everything in this bracket becomes the value for u. Everything in this bracket is my u. And next up, if that is true, please, this is always equals to y. So if that is true, we know that y becomes everything in the bracket, which is 2 here, this one first. We already say all of this one is u. So I'm going to put u here. You know, when you multiply 2 times, if you remove all this one and put this u, because we say let u be all of these things. So if you put u here, we're going to have that y becomes 2 into bracket u raised to the power of minus 3. Yes, that's what I'm going to have. So I'll have this like this. This is what I'm having. Yes, this is what I'm having as the value for y. Now, going further, what do we note? I also told you that if you check the details very meticulously, I told you that you will know that this is y, and this is y, and this is u. Observe, there is no y, there's no u here. It means that you must differentiate the y, we must differentiate this y, differentiate this u, differentiate this x for us to be able to use the formula. I say that again. You have to differentiate u, differentiate x, differentiate y, and also differentiate u. So for you to be able to use this formula consistently or effectively, which is called chain rule, you apply the differentiation method. So now let's differentiate this quickly. So I'm going to put an arrow here indicating differentiation. So I'm having that du with respect to x. So I'm going to do it like this. So this is how you differentiate u and x. In the same line, you know, we have u and x in the same line. So to differentiate it, just add the u, add d to this u, add d to this x. That's how you differentiate it. So what do we have next? We have that. Now, also, note that whenever you are differentiating, you are only differentiating a value with x. And differentiation is simply the decrease of the power of x. The decrease of the power of x. So how do you do that? Observe. I will take this power 2 now. Remember, we have 2 raised to the power of 2x. Take this power 2, multiply this 2x. So I'm having that 2 times 2 raised to the power of this. And then remove 1 from the power. That means I'm going to rewrite this power and remove 1. So do the multiplication. This times this one, I'm having 4x. This minus this is 1. You can put 1 like this, or you leave it as 4x. You are correct. So I told you that we don't need this one because this does not have x. So we really don't need it. So you jettison it. So what do we do now here? We're going to have that. This part now, if I differentiate this part, leaving this one out because this becomes 0, we're going to have this. We're having 4x here. That's what we're having. Next up, going further next. If I differentiate this value here now, I'm differentiating the y. So I told you that you add d to this or delta to y and also d to u. So now we are now going to have what? We're going to have that. I will use this power multiply this and reduce u. So don't forget. So we have that 2u raised to the power of 1 over 3. So I'm using all of this one now to multiply this. So I'm having minus 1 over 3 here times 2u. I will remove 1 from this as well. Minus 1 over 3 minus 1. That's what I'm going to do. Remove 1 from it. So because this one is a fraction, make this a fraction. Make this a fraction so that it can be easier for us to work with. Now, what is next now? Observe, please, that this one multiplies this one. So when you do that, we're having minus 2u over 3 here. Then I'm having that u. Find my LCM here. What's my LCM here? My LCM is 3. 1 in 3 is 3. 3 times 1 will give us minus 1. And 3 in 3, sorry, is 1. 1 times 1 is giving us minus 1. Then this minus, bring it down. 1 in this is 3. 3 times this one now will give us 3. So from here, I will now say 2u over 3 here. 2u over 3. Please, the u is supposed to be 1. 2u over 3 here will now give us what? Minus this one will give us minus 4 over 3. That's what I'm having there. So in this place now, my divide du now will write minus 2x, then minus 2u, please, raised to the power of what? Minus 4 over 3. Remember this 4 over 3, and then I have over 3 here. I'll put it like this. So this becomes how you differentiate this. So at the point you have already differentiated this one now, at that point, you can now employ the formulae. Because we now have du dx here. Now this is my du dx. I also have dy du. This is my dy du. Please bear this in mind that you cannot use this value because we say let u be everything in here and let y be 2 into bracket u raised to the power of minus 1 over 3. You cannot use u and y to solve because in the formula we don't have u and y. We only have dy over du over dx. So that is how it goes. So I've gotten that here now. So what do we do now? We simply say here, applying chain rule. To apply chain rule there now, I will now have that. It's going to give me dy over dx here. That will give me dy over du. And then this will give me du over dx here. So this is what I'm going to have here. Now, what is the next thing here I understand or we are to do here? The next thing is that we are going to now bring this one because we are always looking for dy over dx in differentiation. We are always looking for this. This is what we are looking for. So I already know my dy du. What's my dy du here? Look at this. My dy du is all of this one. Dy du here is all of this. So I'm going to have minus 2u raised to the power of minus 4 over 3 all over 3 times. Next thing there is my du over dx. That means I'm saying that anywhere you see dy du, look at this, dy du, remove that thing now and put all of these values there. Next up, we have du over dx. Remove the value, remove this du over dx and put this value there. So I'm having here to be 4x. Now going further, I know that my dy dx here will give me, this one will affect the numerator. So when you do that, we're having minus 8u raised to the power of, remember there's x, please. Let's start with x. I have this. Then raised to the power of minus 4 over 3 here. Don't forget we have our over 3 here. Don't forget that. Over 3 here. So now we now have that dy over dx here. Will give you what here? Everything becomes, I'm going to apply indices now. I want to remove this minus. So please, when you have this to remove, I want to remove, let's say we have minus 1 over 2. If I want to remove this, how do I remove this minus here? It's simply the same thing as writing, because it is all belonging to this one. It's the same thing as writing 1 all over, then 1 over 2. Write 1 over 2 down. So it's the same thing. It's the same thing. So from here, if I want to remove this minus, observe that the minus will be for this value. Watch. This is what I'm going to do next. What I'm going to do. First off, I'm going to separate, because observe that this minus is on top of this u alone, not this 8x. So what do I do going further there? I'm going to separate it. So I will say my dy over the x here will give me the separation of minus 8x times. So applying the indices rule now, where we have this value, if you remove this one here, we're going to have 1. So the 1 will press u raised to the power of 4 over 3 down. So that becomes u raised to the power of 4 over 3. That's what we are going to have here. So here, I'm going to now do it like this. 1 from this point, 1 all over u raised to the power of 4 over 3. So this is it. Don't forget we have over 3 down here. So everything at this point becomes over 3 here. So going further, what's the next thing I'm going to do? Note that I can do it like this. Minus 8x times 1 will eventually gives me 8x, minus 8x. So what's the next thing now? This can multiply this times this one will give me 3u, then 4 over 3. So because the question came in the form of root, remember we are the one that removed the root. I'm going to take it back into the original form, that is in the root form. So that will give us minus 8x all over. Now, this is how you do it now. I'll write this 3 out first. Then I will now put a root outside it. Remember, this 3 is outside. Okay, let's put it in bracket like this. So I will put this 3, this down 3 first. I'm having it like this. And then I will put on the value for my u. What is my u from the beginning? This is it. We said let u be all of this one. So I'm going to have it as 2x raised to the power of 2 plus 5. This is what I'm having here. Now, all raised to the power of what? 4. 4 here. So this is what we have as our final answer. Please do well to note that you have got to understand indices. Indices is intertwined into solving differentiation. If you don't understand how indices work, it's possible that you will not get the real value. Thank you for watching. See you in the next class. Bye-bye.